All right, so here we go. What we're going to do is the exact same thing we did in the last video, where we're looking at mole ratios. And that is something that's it's not too complicated. And what we're doing is just adding one step with this to make it a little bit more realistic. We don't measure stuff in moles. Moles is always a calculated value, because the mass of different things is different. So if I have 10 grams of iron, that is not the same number of iron atoms as 10 grams of potassium. But grams, mass, is what we measure. So we're going to look at this as a mass conversion. So we're going to start with mass A, mass of what we are given. First thing we're always going to do is convert that to moles. Remember, jokingly before I said, if you ever don't know the answer, just guess moles. Not that it's always going to be right, but more often than anything else. Moles is the universal currency. So if I want to convert from one material to a different material, I have to do that in moles. So whatever they give you, convert it to moles. If it's already moles, congratulations, you're done with step one. Now that, you're going to use your periodic table. Anytime we see grams and moles together, you're using the molecular mass or the molar mass from your periodic table. Once you have moles of what you start with, you're going to convert that to moles of what you want. That's where the mole ratio comes in. That's where your balanced equation comes in. Now, note to yourself, kind of ingrain this into your mind, because this is probably the single most common mistake. This step, converting from moles of one thing to moles of something else, is the only place that the coefficients in the equation matter. That's it. They do not affect the molar mass. So if I have 2 HCl's, the molar mass is still 36.46, I think, something like that. It's still just the mass of one of them. That 2, that coefficient, doesn't come in until this step. And then once you have moles of what you want, convert that to mass using, again, your periodic table. This is classic stoichiometry. This is what most of the examples we're going to do are going to be. Convert grams to moles, moles of what you have to moles of what you want, and then convert that to mass. Occasionally the question just asks for moles, so you can skip the last step. Or it gives you moles, so you can skip the first step. But it's that middle step, converting from moles of one thing to moles of something else, that's the step that makes it stoichiometry. So, an example. How many grams of silver chloride can be produced from the reaction of 17 grams of silver nitrate and excess sodium chloride solution? Now, I'm going to do some pausing as we go through this. The most useful way to do this is a process skill, is to work it out on scratch paper. So I'm going to walk you through the steps, but you're going to remember a whole lot more if you actually do the math. So grab a periodic table, a calculator, and something to write on. So if you need to pause, do that, and then come back. Hey, welcome back. So the first thing we need is a balanced chemical equation. That is the absolute first step. So if you need to, pause again, do exactly what we did in the last chapter. What are your reactants, your products, and then balance it. So shut me up, see what you can do. Okay, so balanced equation. Silver chloride is produced, so it's on the product side, from silver nitrate and excess sodium chloride. And okay, I was a bit mean. Notice I didn't put the sodium nitrate in there. It's left over. It's all the things that are left over. You know, there's sodium at the beginning, there must be sodium at the end. There's nitrate at the beginning. Hey, look, there it is. It's a double replacement reaction. So, okay, I'll cop to that. That was a little sneaky. Once we have the balanced equation, and this one's easy because it's 1 to 1 to 1 to 1. Makes life a lot simpler. Once we have that, what I do is I pull out the information from the problem. That way I don't have to go reading back through it every time. So in this case, 17 grams of silver nitrate with excess sodium chloride. I love that excess. When it says excess, that means I don't have to worry about the sodium chloride. It's a non-issue. We want to find grams of silver chloride. Okay, good enough. Find the moles of what you're given. Take what they give you, 17 grams of silver nitrate, convert it to moles. Pause, do that, come back. Welcome back. Okay, so we start off with 17 grams of silver nitrate. I'm going to convert from grams to moles. Okay, notice from grams to moles. Grams on the bottom cancels out grams, leaves us with moles. Silver, 1 silver plus 1 nitrogen plus 3 oxygens is 169.88 grams per 1 mole. Divide that and we get 0.100 moles of silver nitrate. It's almost like I planned it that way. Nah, couldn't be. Anyway, so now I have moles of what I start with. I want to find the moles of the desired substance. So this is where my BCA chart comes in. Now this is going to be an absurdly simple BCA chart, to the point where you look at this and you go, I'm just not going to use BCA charts. Okay, with this one, yeah, you could probably get away without it. But unless you're operating at a pretty high level with these, at least for now, do this. It makes a world of difference when you have different coefficients. And again, later at the end of the chapter, this will really save you. All right, so 1 to 1 to 1 to 1. At the beginning, we figured out we have 0.100 molar of the silver nitrate. We have excess sodium chloride, so I don't care about that. And I don't have any of the products. Now, only one of those products actually matters, but okay. So we use up the silver nitrate. It's completely used up to 0. And 1 to 1 ratio, so all right, it's going to give us 0.1 molar and 0.1 molar, or 0.1 moles. Sorry, molar is something different. So that is what I'm after, moles of silver chloride. But the question asks me for grams. So I start with my moles of silver chloride, and I convert that to grams of silver chloride, same way we did the beginning. And there we go, 14.3 grams of silver chloride. That is our final answer. Now, kind of looking ahead a little bit, once you're getting better at this, to the point where what I'm about to show you makes perfect sense. If you look at it and go, well, yeah, obviously, that's, you know, I understand everything about that. That's how I wanted to do it. When you are good with all of this math, when you understand it well enough that you've explained it to your 8-year-old brother and he's now doing your homework for you, then you can do it this way. Notice it's all the same parts. Rather than doing it in 3 steps, I do it all together. But notice, first I start with grams of what I have, convert that to moles of silver nitrate. Moles of silver nitrate convert to moles of silver chloride. Moles of silver chloride convert to grams of silver chloride. and that's where I end up. Now, all the same thoughts, all the same math. One thing with this, if you're doing it this way, do not mess this up. What most people like to do, especially if you're looking at it going, yes, shorter way, I will do the shorter way, and people just don't write down units. Now, in this case, it's 1-to-1 either way, but probably the most common mistake for people that are doing it this way, with this method, is on this step. They just write down moles and moles, if that. And instead of 2/1, they get 1/2. And it's wrong. Yeah, it's almost right, but the term for something that is almost right is wrong. So be careful. Write out the units, not just grams and moles, but grams of what and moles of what. And if the units line up, you'll be fine. All right, that is about that.